Today we are going to be reviewing factoring. So we're going to be factoring by finding the GCF, by grouping, and by guess and check. So remember, the concept of factoring is when we have a polynomial containing the sum of monomials means finding an equivalent expression that is a product. So we're trying to take this polynomial, so things being added and subtracted together, and turn it into terms being multiplied together. So the very first thing you should always do when you are factoring is look for a greatest common factor. So the greatest common factor, also known as GCF, is an expression of the highest degree that divides each term of the polynomial. It is the reverse of what we think about as distributing. So we are trying to look at terms, what do they have in common? We pull that out, and then whatever is left over is back in the parentheses. So let's look at a few examples. Here I want to factor 10x to the third minus 4x squared and 2x times the quantity x plus 7 plus 3 times the quantity x plus 7. So once again, our very first thought should be, I want to look for a greatest common factor. So in the first one, I see I've got some numbers. I want to find out what's the biggest number that 10 and 4 have in common. And so because 4 is smaller than 10, the first thought is, can that smaller number go into the bigger number? Because if I can multiply 4 times something and get 10, 4 is the greatest number that they have in common. But I can't multiply 4 times something to get 10, so I'm going to start breaking 4 up and seeing, okay, can I find another factor of 4 that's also in 10? And so since 4 is 2 times 2 and 10 is an even number, they both have a 2 in common. So 2 is going to be a part of that GCF. As far as the variables go, if both terms have the same variable but their exponents are different, the smaller exponent is what they have in common, so x squared. So 2x squared is the GCF, and then if I factor that out by basically now dividing 2x squared into both of those, well, 10 divided by 2 is 5, and if I have x to the third, but I took out x squared, I'm left with an x. Bring down the subtraction sign, 4 divided by 2 is 2, x squared divided by x squared. If I have x squared and I take out x squared, there's no more x's. And so because there's nothing in parentheses, 5x squared minus 2 that they have in common, that tells us that we did find the correct GCF. I can't factor for 5x minus 2 any further. So by factoring out the GCF, we got our answer. In the next one, notice that both of the terms contain the same thing in parentheses. There's an x plus 7 in both of those parentheses. So that is what both those terms have in common. They have that binomial in common. So if I factor out that binomial of x plus 7, notice what's left over is what was in front of those parentheses. So we have a 2x plus 3. 2x plus 3, there's nothing else that those two terms have in common, and so by factoring out that GCF, we were able to get our final answer. So that second example is going to help us kind of get into this concept of factor by grouping. When there are 4 terms and you are asked to factor, we group the first 2 terms together and then the last 2 terms together, and we look for GCFs. If the remaining terms are equivalent, then we can go ahead and finish factoring. So here we've got 4 terms, x cubed plus 5x squared minus 2x minus 10, and I want us to factor. So once again, we are going to group the first 2 terms together. So we're going to have an x cubed plus a 5x squared in parentheses plus, because I always want an addition sign breaking them up, notice that the last 2 terms are really a negative 2x minus 10. Okay, so I grouped the first 2, I grouped the last 2. I always have that addition sign breaking up the 2 groups. Once I've done that, now we're going back to the thought process of let's factor out GCFs. In the first 2 terms, what GCF do they have? Well, they both have variables, and once again, I take the smaller exponent, so x squared is what they both have in common. That leaves us with an x in the first term and a 5 in the second term. I'm going to bring down that addition sign, and now I'm going to look to see, okay, negative 2x minus 10, what do they have in common? Well, they both are even numbers, and because there's a negative sign in front of the 2, I'm going to factor out a negative 2. So when I divide both those terms by -2, that leaves you with an x. A negative divided by a negative is a positive. And so we'll have x plus 5. Notice that we're on the right track then to be able to finish factoring because both of those GCFs taken out left us with the exact same thing in parentheses. And that kind of takes us back to that last example that I looked at. So now both those terms have an x plus 5 in common. So if I factor that out, that leaves us with an x squared minus 2. X squared minus 2 doesn't have anything in common. I'm not going to be able to factor that any further, and so this would then be my final factored answer. So take a second and pause the video and see if you can factor both of these examples. So hopefully when you factored the first one, you saw that they both had a 7 in common. So factoring out that GCF then left you with 7 times 2x minus 1 as your final answer. With the next one, hopefully you recognize that we had a factor by grouping. Taking out what they had in common with both of those parentheses, we ended up with an x minus 2 left over in both of those terms, which allowed us to factor even further to x minus 2 times 5x plus 3. The last concept that I want to look at is when we're starting with trinomials. So factoring trinomials with the lead coefficient of 1. So it looks like x squared plus bx plus c, where b and c are different numbers. We are asking ourselves what multiplies to c but adds to b. So if I'm looking at factoring x squared plus 13x plus 40, notice that there's no number in front of x squared. Notice that there is no variable at the very end. So there's not going to be a GCF in common because there's no numbers that they all have in common and there's no variables that they all have in common. So my thought process is what multiplies to the last number but adds to the number in the middle. So we're asking what multiplies to 40 but adds to 13. So that's going to create then two binomials. It's going to start off with an x and an x in each of my binomials because x times x is x squared. So what multiplies to 40 but adds to 13? Well, 5 times 8 multiplies to 40. 5 plus 8 adds up to 13. So that gives us, this will let me write, a positive 8 and a positive 5. Now, if you have the 5 and the 8 switched around, that's perfectly fine. And this would then be my final answer. Same idea with the next one. If you look and you see this trinomial, there's no number in front of the x squared. There's no variable at the end of the 14. So there's no number or variable that they have in common. So I always look for that GCF, but sometimes you don't have one. So then that once again tells me I'm asking what multiplies to the last number but adds to the number in the middle. So this time, take into account that we're dealing with some negative numbers. So what multiplies to a negative tells us that one of our numbers is negative and one of our numbers is positive. Once again, because our first term is x squared, x and x are going to start off each of our parentheses. So what multiplies to a negative 14? Well, negative 7 and positive 2. And notice negative 7 plus 2 is going to get us that negative 5. So once again, the negative 7 could go in the second parenthesis, the positive 2 could go in the first, but this would then be my factored answer. So now, if I'm still focusing on factoring trinomials, but this time I have a coefficient that is greater than 1 to start us. This would be then this guess and check method. So ax squared plus bx plus c. So a, b, and c are all numbers. So it says we start by finding multiples of both a and c. Then we will basically take those multiples, guess where we want to put them, and then check to see that with those numbers that we have, the products of both the inside and the outside add up to then that middle term of b. So if I want to factor 6x squared plus 19x minus 7, I'll once again look for a GCF first. I have a number in front, 6. I've got 19, I've got 7. So there's no number that they all have in common. And then there's no variable at the end. So there is no GCF. And because we weren't able to get rid of that 6 in the front, that tells us that we look at all the multiples of 6. Well, there's 1 times 6 and there's 2 times 3. So we're going to use one of those two numbers when we start our parentheses. The nice thing about 7 is that it's a prime number. It's 1 and 7. So when I'm starting my guessing, If I want to figure out, okay, well, what multiples do I want to start with? I'm going to start with the 2x and the 3x. So once again, the x's have to go with it because x times x is going to get you that x squared. But 2 and 3 is my guess for what multiplies to get me 6. So now I'm going to guess, okay, where do I want to put the 1? Where do I want to put the 7? Keep in mind that the 7 is negative. So one of those numbers is going to have to be positive and one of them is going to have to be negative. So I'm just going to guess, okay, well, let's make the 7 positive first and then the 1 negative second. So now I've done my guessing. And then, like I said, now we have to check to see that the products of the inside and outside terms get you that middle number that gets us this 19. So I'm going to multiply the outer terms together. 2x and negative 1 multiply to a negative 2x. I multiply the inside terms together. 7 times 3x, that gives me 21x. If I combine those like terms, 21 and negative 2, that will get me my 19. So that tells me that I guessed correctly the first time around, and so I'm done. Had I not gotten that middle term, then it would have been a matter of me maybe flipping the 1 and the 7 around, or maybe going and switching the 2 and the 3 to a 1 and a 6. Same idea then with this next one, 4x squared minus 11x plus 6. I look first for a GCF. If I'm looking at my numbers, 4, 11, and 6, well, they're not all even numbers, so we're not going to find something that they all have in common. They don't all have a variable, so there's no variable in common, so there's no GCF here. So there's still that lead coefficient of 4. So that tells us that we can have 1 times 4 to start us off, or we could have 2 times 2. Going to the last number, we've got 6. So that's 1 times 6 or 2 times 3. So we have a few more options here when we're doing our guessing and our checking. But if we start our guessing process, since I want to figure out, okay, what's, do I want to do 1 and 4? Do I want to do 2 and 2? I'm going to do 1 and 4. So I'm going to put the 4x first and then the 1x or just x second. And that multiplies to get me my 4x squared. Now, because we're talking about multiplying to a positive 6, but then my middle term is negative, we have to recognize that the only way to multiply to get me a positive but add to a negative, both of those have to be negative. So now it's a matter of, okay, do I want to check or guess with the 1 and the 6 or the 2 and the 3? I'm going to say let's do 2 and 3. The nice thing about this is that the 2 is not going to be able to go with the 4 because then within the parentheses, there is a GCF. But I already determined that there was no GCF in this entire trinomial. So that means that the only option is that I have to put the 3 first to go along with the 4 because that doesn't have anything in common. Had I chosen 1 and 6, the only number that could have gone with the 4 was the 1 because 6 and 4 would have a number in common. So that means that the 2 goes over here. I've done my guessing. Now let's do our checking. Remember, I want it to add to negative 11x in the middle. So I'm going to multiply the outside terms, 4x and negative 2. That will give me negative 8x. Then I multiply the inside terms. Negative 3 times x is negative 3x. When I combine those, I will end up getting that negative 11x. So once again, I was able to get that on the first try right away. Sometimes you won't, and that's perfectly fine. I would suggest do not erase your work. Just try it again off to the side, okay? Because you don't want to keep erasing things and then having to go back in circles because you're like, oh, did I try this one? Did I try this one? Because there could be potentially a lot of different ways that you can mix things up if you aren't just showing all of your work. All right, let's look at this one. If I want to factor 3x squared minus 13xy plus 4y squared. Once again, I'm going to look for a GCF. If I look at my numbers, 3, 13, and 4, they don't have anything in common. If I look at my variables, not every single term has all of the same variables. So there is no GCF. So there's still that lead coefficient of 3. The nice thing about that is that it's a prime number. So the only way to multiply to that is 1 and 3. 4 could be 1 times 4 or 2 times 2. So then now we have to go ahead and do our guessing. So I'm going to have my only option would be a 3x and a 1x. But now with the last terms, when I pick my numbers, I also am going to have to put a y with it. So then it ends up being y squared at the end. Because it multiplies to a positive but adds to a negative, just like our last example, both of these numbers are going to have to be negative. And then I'm going to decide between 1 and 4 and 2 and 2. So I'm going to do 1 and 4. But remember, once again, I'm going to put a y with each of those numbers as well to get to that y squared at the end. So I'm going to do the 1y squared, or sorry, 1y first and then the 4y second. And now I'm going to check to see if I get this middle term of this negative 13xy. So when I multiply the outside terms, 3 times negative 4 is negative 12. There was an x as well as a y. When I multiply the inside terms, negative 1 times 1 is negative 1, and there is an x and a y. So when I combine those like terms, notice negative 1 and negative 12 does get me that negative 13. So I guessed correctly the first time around. Pause the video, see if you can try factoring these. Hopefully you were able to get the first one. And once again, if you have the negative 9 and the 5 in the opposite part of your parentheses, that's perfectly fine. And then with this example, hopefully you got 5x plus 2y times x minus 8y. So the 5x and the 2y have to go together. There has to be a positive sign. But if that whole thing was switched to the second parenthesis, that's perfectly fine. All right, and then we've got this difference of two squares for factoring. So it says if a and b are real numbers, variables, or algebraic expressions, then a squared minus b squared is going to factor into a plus b times a minus b. Okay, so take two terms, square them, but notice that there is a subtraction sign in between them, the difference of two squares. That's going to allow us to come up with this pattern. So if I want to factor, notice that x squared, well, that is a squared term. Notice that 81, that is a perfect square number. Notice that this is technically 9 squared. So this is why it falls under that difference of two squares. Notice that there is no GCF. Once again, you always look for that GCF first. But in this case, an x squared and a 9 squared, there's nothing in common there. But because it's x squared, I know I'm going to have an x and an x. Because it's 9 squared, I know I'm going to have 9 and 9. But because it's a negative, I know one of the 9s is going to be positive and one of the 9s is going to be negative. Notice that if I was to check the middle terms, you would have a negative 9x and a positive 9x. And so that's why there's no x's in the middle, because they end up canceling out. And that'd be my factored answer. 36x squared minus 25. If I look to see if there's a GCF between a 36 and a 25, there's just no numbers that they have in common. So no GCF. But notice that 36, that's a perfect square. That's 6 squared. Notice that 25, that's a perfect square because that's 5 squared. So once again, we have this idea of perfect square or difference of two squares. So when I do my factoring, I know that it's not just going to be an x and an x, but it's going to be a 6x and a 6x because that multiplies back to getting me that 36x squared. Because it is subtraction, I know that I have to have one of them positive and one of them negative. And then because 25 is 5 squared, we'll have a positive 5 and a negative 5. And there is my final factored answer. Once again, pause the video, see if you can come up with this. Okay, so hopefully you noticed that there was no GCF. 49 and 121 are both perfect square numbers. 7 and 7 is 49. 11 and 11 is 121. But also realize that you had variables with both of those terms. And so that's us factoring by finding the GCF, grouping, and guess and check.